Hi, this is David with Seismic Rocks. Today I'd like to discuss Seismic Unix import and export, but because this is part 2, this is just the import part, and today we'll be looking at a bit of a complicated SEG-Y file for import. Before we get started with that, let's go ahead and look at what resources we have. So over here we have the Seismic Unix wiki, and we have documentation, and then we have SU data format. So let's keep in mind what we have here is the key, the length of each key, and the corresponding bytes in the SEG-Y file. There's another reference site, which is my own website, Seismic Rocks, and over here we have SEG-Y, and we have these tabs, and here's the 240 byte trace header with similar information. So we'll be going to one or two other of these during our import efforts. Now let's go ahead and cd to my work directory, and ll. I like to use ll. Alias ll is a long listing of the file here. I also like to use llrt, which is a reverse time. R is reverse, and then T specifies that it's a time reverse in addition to, so the R is the alphabetical reverse, and T says in addition, or instead of an alphabetic reverse, let's do a time reverse. If there are a lot of files here, then this is a very nice way of ending up with at the bottom with my most recent file. Now we have this TS file. We'll be working with this one today. This is Teal South Gulf of Mexico Marine Dataset. And to make things a bit easier for me, let's go ahead and copy this from the very long name, or somewhat long name here, to simply ts.sgy. Okay, it's not a very big file. It's 5.3 megabytes. Okay, and we'll be using SEG-Y read, and here we have set up SEG-Y read. So the SEG-Y file here, tape specifies the SEG-Y file name. H file, as discussed in part 1, is for specifying a name of the header block, the textual header block, instead of letting it default to a thing called header. And B file is, instead of letting the import default to a thing called binary, here I give it a specific name, ts.bin. I'll use SEG-Y clean, again as discussed in part 1, but we'll get back to discussing SEG-Y clean for this particular dataset. And then our output dataset, ts.su. Let's go ahead and run this and see what we get. So that seems to have been run correctly. So we have a binary file, textual header file, 400 bytes, 3200 bytes, and the Seismic Unix data. Let's, for grins, let's XUX wig B. Let's use image ts.su, and I like to use a perk value. So let's see what we have. So these appear to be flattened shot gathers or CMP gathers, probably CMP gathers. Alrighty, nothing too exciting to see here at first. It was just to prove that the import worked and we could read the data. Now let's talk about SEG-Y clean for a second here. Let's repeat that import command, but I'm not going to use SEG-Y clean, so I'm going to call this ts.dirty. And we can repeat the plot command. cannot allocate memory. So something went wrong with that because of not using SEG-Y clean, I presume. Let's go ahead and go to space here. And SU range, let's look at the headers of the dirty file. Now, we've discussed before the importance of the fact that Seismic Unix works with, out of the 240 bytes in the Seismic trace header, Seismic Unix actually, of the SEG-Y header, Seismic Unix actually only works with the first 180 bytes. And if we go down here to around 180, we'll see that in fact there are names, there are SU keys for bytes beyond 180, but these are only for use by Seismic Unix internally. Normally, the user doesn't have anything to do with this. So we have D1, F1, D2, F2, UngPow, Unscale, NTR, and Mark. But if we look at the SU range output, we see that there are, well, this is just an incredible number of some sort in D1 and D2. UngPow, Unscale are decimal zeros. NTR has some values, and Mark has some values. Now, if we go SUDoc, SUX image, we see that D1 and D2 and F1, F2 are used internally by the plotting program. I don't know which of these prevented the file from being plotted, but the fact is that we see in the SU range program output that there are values where we don't want them, and that's why we use SEG-Y clean. Let's go ahead and look at the Seismic Unix, the header file, textual header file, which would be ts.txt. And because this window is set wider than 80, or not at 80, then we have a strange output from that ls command, or cat command. So let's do this over again. And let's see what we have. Now, I have no documentation with this data set except for this the SEG-Y file itself. I have no PDFs, I have no Excel files, I have nothing. And so in order for me to understand this data set, the only reference I have is the textual header. So it's critically important that the textual header have valuable information, have pertinent information. Now we see here that in the textual header that this is from a 4D consortium, 4D, 4C, time-lapse, 4D, time-lapse, 4-component. The Energy Research Clearinghouse is the name of this. And this is from Teal South. We have phase 1. This is, again, time-lapse 4D data. So this is from phase 1. It's the PZ vertical component. CDP gatherers, okay, so we know they're not shot gatherers. Now we know they're CDP gatherers from inline 1104. And now we have some information about the headers. Shot number is stored in 9 through 12, 9, 10, 11, 12, 4 bytes. Inline number is in 189, 190, 191, 192, 4 bytes, but this is above 180, so this is going to be of importance to me. The X-line CDP number is in 21, 22, 23, 24, 4 bytes. That's very good. X coordinate bin center, that's the 3D then. This is 3D data. X coordinate bin center is 105, 106, 107, 108, 4 bytes below 180. That's good. And Y coordinate bin center is 205 to 208, which is above 180. 205, 206, 207, 208, 4 bytes. And receiver number is in 181 to 185. 181, 182, 183, 184, 185, that's 5 bytes, which can't possibly be true. So, because if we look up and down the Seismic Unix information here, we will see that and as far as Seismic Unix is concerned, there are only 2 or 4 byte useful holders, keys. So this is either bad news, 5 bytes, or to typo. And I'm going to go ahead and pretend that this is a typo. So I'm going to pretend that this is actually stored, the received number is stored in 181 to 184. Okay. Now, I created a table. Let's go ahead and try to figure out where I put that table. Here, I think. So here's my file stuff. Let's look at this. Now, from that information from the textual header, we have the header words listed. We have the SEG-Y bytes that were told to us. And this is a critical question here, above 180, below 180. Now, I made another table. Let's see if this is of more use to us. So I'm going to use SEG-Y read parameters bytes and remap. So what I'm going to do is, for example, in 205, 208 is above 180. So I'm going to remap, as it's called in SEG-Y read. I'm going to remap these bytes, 205, 208, to GWDEP. And that's the Y coordinate bin center. Now, X coordinate bin center, I show here that I'm going to remap this also, but this is below 180, so why am I bothering with this remap? Well, let me show you why. 105 to 108. Looking at the key header table, we see that 105 to 108 is not available as 4 bytes. That is, it's available only as 105, 106, and 107, 108. So if we let the bytes in 105, 108 just slam into lag A, lag B, then the data is going to be split. It's going to become corrupt. These 4 bytes will become corrupt. So I can't let them go into 105, 108. It's not a 4-byte key. It's 2 2-byte keys. So the data will become corrupt. So instead, I've gone ahead and selected to choose to put the 105, 108 into SWDEP and 205, 208 into GWDEP. And this is 61 to 64 and 65 to 68. Let's take a look at what we have here with that. So SWDEP, water column height at source location, water column height at receiver group, or the G for geophone, I suppose, but it's water, so it's not a geophone. Now, let's go ahead and get back to where I used SU range. Let's go ahead and not use it on dirty, but use it on SU. Now, SWDEP and GWDEP are being used right now, but I need 4 bytes, and there are not a lot of 4-byte keys in the Seismic Unix header. So and a lot of these are being used. You can see this. I'm very surprised by how many headers are being used, how many keys are being used by this particular data set. So I'm going ahead and I've chosen to overwrite because I don't plan to do anything with water column depth. And that's my choice. It's just because I don't plan to do any research with these particular values, I'm going to overwrite them. It's that simple. So 9 through 12, I'm going to not remap them. They're fine by me. Inline number is 189, 192, and I'm going to put those into CDPT. Why CDPT? we see here that CDPT and track F appear to be duplicates. And I used program, I think it's SU-get header word, SU-get HW, to test whether those are indeed duplicates. And they are. We also see here that track L and track R appear to be duplicates, and again I used SU-get header word to test whether those are duplicates, and they are. But the thing I like about CDPT is that I have inline number here, and I have CDP number, and so what I'm doing is putting the inline and crossline numbers next to each other. So this will go into CDP all by itself. So that pretty well explains what I'm doing with these numbers. Now, again, I'm assuming that receiver number 181 and 185 is a typo here, and I'm assuming it's 4 bytes, and I'm putting that into SDEL. And why SDEL? It's because it's not being used. If you don't see a key printed from SU range, it means that either all of the values are 0 or there are no values. Same thing for SU. As far as SU range is concerned, that's all the same thing. If so, for example, we look at NVS. So what this tells me is that either all the traces have the value 1, the traces that have values at NVS are 1, either of those two. So because SDEL is not showing up in this list, it means it's free for me to use. Now the next thing I need to show you is a discussion inside SEG-Y read. And we look at this table here in SEG-Y read. So part of the mapping and remapping and the byte and remapping parameters, we need to use one of these 4 as part of the remap parameters. So F means I want to put the value from SEG-Y into a float key, or I want to put into and so that would be 4-byte float. The L means a 4-byte long int. S means a 2-byte short int, and B means a 1-byte. I have no reason for using B today, and today, in fact, I have no reason for using S. So I'm either going to be choosing to remap using the F for a 4-byte float or L for a 4-byte int. So let's see how I do that. Well, that was pretty unexciting for you, I know. But let me explain what I just did. So I give the starting byte for the remapping. So I want to remap to CDPT. So I want to remap long int, 4-byte long int, starting at 189L, 4 bytes to CDPT. I want to remap float, 4-byte float, 105, starting at byte 105 in the SEG-Y header, to SWDEP as the SU key, etc., etc. Now, why am I doing long int versus float? I look over here. Now, it's my experience that when I see a label of number, that is an integer. And it's my experience that when I see a coordinate, that is a float. And that's why I've chosen to do this. Let's go ahead and try that and then see what we get. And you can see that what I'm doing is overwriting my imported file over and over again. I overwrote ts.su, and I overwrote the textual header file and the binary header file. It just doesn't matter to me. I just experiment until I get this right. So let's see how I did. CDPT turned out to be 1104, which actually makes a lot of sense. Because CDPT, I was importing the inline number, and remember that the textual header said that that this data is apparently extracted from a single inline, 1104. So that's good news. That seems very nice. SWDEP and GWDEP. So I have a very large negative number, a very large positive number, and GWDEP is not here. So that's not good. It means GWDEP is all zeros. So I'm not happy with what I did here with SWDEP and GWDEP. Moving on to discuss SDEL. We have SDEL, and we have some numbers, and I don't know whether to be satisfied with these numbers or not. I just don't know what to say. Now, getting back to SWDEP and GWDEP, what I did here was to import them as floats. So I don't like what I got. So I'm going to presume that I made a mistake in assuming that coordinate is float, and I will now try importing these coordinates as int. So let's go ahead and back to this. And make that an L, and make that an L, and let's review SWDEP and GWDEP. And these are, I have numbers, and they look quite reasonable for both of these. And so what I would do is say that I'm happy with this import, and I would move on to using this data set. And also let's note that because I use SEG-Y clean, that I no longer have this information, that is the in the higher number bytes, the 181 to 190 or wherever they were, that would interfere with the plot. So let's go ahead and try that again. So the clean data set seems to be working fine. That's the byte and remap parameters, very critical for getting information that is stored in the SEG-Y header in bytes that are beyond 180, or perhaps in bytes, as we discussed before with lag A and lag B, that are where information, excuse me, I've lost those puppy dogs. Here we go. Where information that is 4 bytes in the SEG-Y header is going to land on top of 2 bytes. So we want to avoid that, and those are critical problems to watch for. Well, thanks a lot for your time. I appreciate your comments for review of this and suggestions for other videos to make, other tubes. And please like if you like, and please subscribe if you subscribe. And I'll see you next time. Bye-bye.